So now we are going to do one of my favorite problems on LeetCode, that is called task scheduler. We can see that this one is a medium problem and also a very well-liked problem. Now I just have one request for you. I really want you to pay utmost attention to this particular problem, because if you can understand to solve this problem, there are a lot of important LeetCode concepts that would enshrine in your brain. So please, please, please pay utmost attention. Now let's get started with the question. Basically, we are given an array of CPU tasks, and each task is represented by a letter somewhere between A to Z. Then we are also given a cooling time N. Now we are told that each cycle or interval allows the completion of one task. Okay, that's fine. And then we are told that task can be completed in any order, but there is one small constraint regarding this interval N that we are given. And that is that identical task must be separated by at least n intervals due to cooling time. Okay, so let's try to understand what it just mentioned with some examples. And basically we need to return the minimum number of intervals required to complete all the tasks. So let's try to understand this with an example. In this case, we can see that we are given three tasks that we need to complete. First task is A, second one is B, and third one is once again A. We are also given the cooling down period of 2. Now, how does this cooling down period affect our task is that identical task must be separated by n intervals. So let's assume that during the first window, we start to complete task A. Okay, so we got rid of this task. Once again, we got rid of this task as well, task B. Now the thing is, we only have one task remaining that we need to complete, but if we try to complete task A over here, and if we see the difference between this interval and this interval, then we can see that the difference is only going to be 1. But the thing is, it has to be separated at least by 2, because that is what the cooling period is. Because once again, I'm repeating, both A and A are identical tasks. We are told that identical task must be separated by at least n intervals, and in this case is 2, which means two identical tasks has to be separated by 2 intervals. Currently we only have it separated by 1 interval, so we will actually have to add one more interval over here where we are not going to do anything. So this would be an idle period where we are just going to stay idle just to complete that one more interval. And now we have 1 and 1, 2 intervals completed after we completed task A, and then once again we can complete the remaining task A. So totally we need to return the minimum number of intervals required to complete all tasks. And in this case, we can see that we took 1, 2, then this idle third, and then this completing A4. So in total, we took 4 intervals to complete this task. Let's try to understand this with a couple of more examples. Next example is, once again, we are given n is equal to 2. Now in this case, we have 3 identical tasks. We have 3 A's and 1 B. So one logical solution would be, we can start with task A. Once again, we go to task B. Now we know that the cooling period is 2, which means we cannot use a task A once again. We will have to stay idle. So we got rid of this one. Okay, now once again we can do task A. But after completing task A, once again the next task we need to do is once again task A, for which we have to have 2 idle cycles. So since there are no other tasks remaining, we are going to remain ideal for 2 more cycles, and then we are going to complete task A. So if we calculate in this case, we need in total 7 intervals to complete every single task in this input. And same way in this approach, we would actually need in total 8 intervals. How? Because we are given 3 A's and 3 B's. So logically we can do task A, then we can do task B, and then we cannot do task A or B once again. So we will do an idle scenario. Once again we would do A, once again we would do B, and once again we would do idle, and once again we would do A, and once again we would do B, and then we don't need to stay idle because we completed all these 6 of the tasks. So that's what the problem is asking us to solve. I know understanding this problem is quite tricky. Now first let's try to understand the brute force approach. Now logically, the most simplest brute force approach would be to try out every single possible permutations and combinations. So we start with task A, then once again we try to find that what is the next task that is not A. Once again, we identify task B. Once again, we mark task B. Once again, we try to identify that is there any other task that we can do that is not A nor B in within this two window period. We cannot find anything. So then we decide to go idle. Once again, we repeat the same process, and once again, we keep on finding the next task. So this is a very slow approach, and we are doing lot of repeated work just to do this one, because number one, we are not sure that how many number of total tasks are available. Number two, we are not sure that what is the frequency of every single task. So we cannot know that during any particular interval cycle how many number of tasks we can accommodate. That is one huge problem with this brute force approach, and this problem is what we are going to solve and exploit it in order to make this algorithm much faster. So let's try to understand that what is the optimal solution I'm suggesting. But for optimal solution, first we will have to build up some logical understanding on how we can improve our solution. Okay. So for that, once again, let's take our favorite example where we are given 3 A's and 3 B's, and once again we are given our n is equal to 2. Logically, most efficient method for us to solve this problem would be that in any particular given input, first we need to find out that what is the character that occurs most number of times, and we always have to start with that character in order to complete it in the fastest manner possible. So logically, in this case, both A and B occurs 3 times. So what I'm suggesting is that first approach we can take, first smart approach is that we can actually take an entire input, run it through some sort of like array or hash map and create a frequency map. And in this frequency map, we are going to make sure that every single time any particular character, how many times it appears. That is number one thing. Next, we will need to learn that what is the maximum time any particular value repeats, and then we will need to store the values in the decreasing order. So once again, we will need to find some way to sort this frequency map. So for that, one of the very good approach we can take is that we can actually create a heap, where inside the heap we can store the information that how many times any particular character appears, and we can actually store its information. So let me just make this slightly different, and we are going to have B appear 2 times. Okay, so now it makes sense that A is 3 times and B is 2 times. Okay, now one more logic I'm suggesting is that we actually take understanding of this scenario, that what is this n represents. So basically this n simply represents that how many number of computations we can do back to back on separate characters during any particular interval size. But the interval size has to be n plus 1. Why n plus 1? Because remember, we want, let's go back to our very first example. Now let's try to understand this logically. First, let's say we add value number A. Okay, then we add value number B. Okay, now how many more operations we can do where we can basically either there can be two options. Number one option is that maybe we have some other value that is not A and not B that we can add over here. That is one option. If that is not the case, another option is that instead of adding this another value, we will need to add an idle value over here. And then the whole cycle of once again reaching out to character number A would reset, because then we would have covered the two destination from this our original value A that we were looking at, which means that in order, depending on the value of n, we would actually have to consider the scenario of n plus 1 as part of one cycle, because in one cycle we can only take unique characters during that one cycle, and if we have less unique characters than this one cycle, then we will have to use idle cases. So which means if we have unique characters, we can simply reduce the values of those unique characters. So in this case, we got rid of this 1A and then 1B. So we are basically reducing the values. Let's say if this one was C, then we could have just reduced C, but we don't have C. So we still have A. So which means repeated characters would only be decreased by 1 during one n plus 1 cycle. And if we have unique characters, we will try to fit as many unique characters as we can inside this n plus 1 cycle. So this is the second improvement we are trying to do of applying n+1 cycles. So let's understood that number one, we already know that we created our hash map. Sorry, we created our frequency map. Then we created a heap to store the frequencies that are coming in. And next we are going to be marking the scenarios based on n+1 cycles. Now these are the three improvements. Now I'm suggesting fourth improvement, and that's why I'm telling you that this problem is such a mind-blowing problem, because you are making improvements after improvements after improvements in order to make the efficient algorithm, and that's why you are learning a lot of new things. So that's why I'm paying my utmost attention. Coming back to the question, so understand in this case that so far we are keen on understanding that how many number of A's are present and how many number of B's are present and how many number of C's are present. The thing is, apart from storing this value inside the frequency map, we don't have any other information that we need to utilize this for. All we can do is that we are already tracking the values based on the cycles. We already have a heap to store the values in sorted order. Now, instead of storing these characters, why don't we just store the frequencies? Because in the end, we simply need to return that what are the total number of intervals we are going to need. So in the heap, we can actually store the frequencies. The idea is we are going to be traveling in the cycle by manner. So cycle in this case is this is 2. So there is going to be cycle of 3s. Okay. And we know that how many number of unique characters are present inside this given input, because inside the heap we only have 2 distinct frequencies. So that's why there are only 2 unique characters present. So this becomes our way to understanding that there are only 2 unique characters. We know that in one cycle we can only iterate over just unique characters and reduce their frequencies. For rest of the time we will have to put the idle slots. And what I'm suggesting is that we initially start our heap this way. Then we are going to run in the cycles of 3s. With every single cycle, we are going to pop the elements out of the heap to make sure that whether heap is empty or not. If heap is empty, if there are no values inside the heap, then we will simply add idle values till we make n+1. So why do we even make idle values? We know that after removing all the elements of the heap, basically for this cycle we still have some elements that for which we haven't calculated the frequency. And if there exists some frequency, which means the entire n+1 has to be part of the answer, and then we simply have to reduce the frequency by 1 and once again repeat the same process. So this is the whole solution I'm suggesting. Now let me quickly show you the optimal approach. Let's walk through the optimal approach and then we will see the coding solution. So if we see the optimal approach now, it is going to make much more sense. Once again, let's take our example, and we have 3 A's and 2 B's and we have n is equal to 2. Okay. Logically we have our heap. So currently inside the heap we only have values 3 and 2, that is the frequency map. And notice that this frequency map is actually sorted based on the ascending order property. Then once again for n is equal to 2, which means we are going to do the cycles of value 3. Okay, so let's try to do the first cycle of value 3. During the first cycle of value 3, we are going to pop one element, this 3, out of our heap. Currently we have, and we are creating a temporary list to store the value of heap, and then we are going to reduce it out of the temporary loop. Okay, so currently this is 3, we popped one element out. Currently this is 2, once again we popped both the elements out, and we realize that currently our heap is completely empty. There are no values inside the heap. So if heap is empty, then we need to check that what was the value that we took out from the temporary loop. We took out the values 3 and 2, which means we will have to reduce these values, and reducing these values are going to be 2 and 1, which means the temporary list is not 0. So in this case, because temporary list is not 0 and our heap is empty, we know that during the first cycle we will have to do 3 intervals. So we are going to mark 3 that we have completed so far. So we are going to have a variable called interval where we are going to store the values. So far we have completed 3 variables. Once again, notice that inside the temporary list we first had values 3 and 2, but we reduced the frequency by 1. After reducing the frequency, once again we are going to populate this value 2 and 1 once again back into the heap. Once again, we are going to run the operation. So once again, in our temporary list, we are going to have values 2 and then value 1 coming in. And we are also going to have a heap becoming empty. Now heap is empty. We try to reduce the frequency. So reduced frequency is going to be 1 and 0. Now after reducing the frequency, we realize that there are still some values present, which means this entire interval we are also going to consider. So it is going to be 3 plus 3 so far. After this, once again, we realize that this value is 0. So 0 value we kick out from the temporal list. We put the value back inside the heap. So currently heap only contains value number 1. Okay, so now after containing value number 1, we will try to pop value number 1 out. Currently heap is empty, but we are not going to add 3 so far because this might be the last character, which is the case because in the temporary list we identify that there is only 1. If we do like a reduce operation minus minus, then this becomes 0, which means temporary list does not have any value and heap only had 1 value. So we are simply going to add that value that we take out from the heap or take out from the temporary list. So in this case, we need to make minimum 7 intervals to complete each of these cases. And let's try to walk through these 7 intervals. So of course, our given n is equal to 2. So first we are going to do operation A, once again operation B, and then we will have to do idle operation. Once again, we are going to do operation A, operation B, and our idle operation. So now so far we have taken out 2 A's and 2 B's, and in the end we simply have our operation A we need to do. So total we need to do 7 intervals in order to complete this problem. And this is the solution. I know I went over a lot of things, but I hope that this made sense, that what I was explaining. If we see time and space complexity in this case, well, time complexity contains a lot of steps. So number 1 step is we need to build frequency map that takes big O of n time. Plus we will need to iterate, we will need to generate the heap. So that takes big O of n log n time. Then we will have to run our while loop iteratively till we reach out, till we complete every single cycle. That is once again going to take big O of n, and then we will have to subsequently do the total number of intervals that we are going to be able to make, and that can, in the worst case scenario, it can be big O of n square. So in total, we can say that our time complexity is still going to be big O of n square, but this is much more efficient approach compared to our brute force that would have yielded us big O of n cube time complexity. So that was going to be horrendous. If we see space complexity, well, we are using frequency map and we are also using heap and plus temporary array list. So basically we are using big O of n extra space, and this is still, in my opinion, a good enough time and space complexity. So here is the coding solution. First thing we are going to do is, for given input task, we are going to run across and create a new frequency hash map where we are going to store the frequency for every single task or every single character. Once we have frequencies, we are going to build our max heap based on the frequency. So we are going to initialize our priority queue to store the integer values of the frequency sizes, and we are going to add all of these values from our frequency map, and they would automatically be sorted in descending order. Next thing is we will need to process every single task. So initially we are going to have our variable time set up as 0. Then we are going to have a condition that while our given heap is not empty, we will need to do the following. So first thing is that we will need to initialize our temporary list that we mentioned that we will have to create. Then we are going to run a for loop from I is equal to 0 to I is less than n plus 1, which means this is going to be one of our cycles. So this is going to be our cycle logic where we are simply checking that we are going to check if the max heap is not empty. We are going to keep on polling every single value out from the temporary list to the temporary array list, and we will keep on repeatedly doing it until our given max heap is either empty or we complete the n plus 1 cycles. In either case, we will have to add n plus 1 items depending on this. Then we will have to reduce the values from the frequencies. So because we are popping values out from our temporary from our heap, which means currently they are stored inside our temporary array list. So we are going to reduce the frequency and keep on checking that if the frequency is greater than 0, we are simply going to add that value to our max heap. If the value is equal to 0, then we are not going to add it to our max heap. Next thing is we will need to update the time, And the time update is going to be quite straightforward, that if the given max heap is equal to empty, then we simply need to update the size by n plus 1. If that is not the case, then we will need to update the size or update the time based on the temporary variable size we had, which means that was the additional values we found inside our temporary array list that got popped out of heap. And in the end, we simply need to return the time, and this should provide us all the intervals we had. So this was a brilliant question, a brilliant solution. Now let's try to run the code. Okay, seems like our solution is working beautifully. Let's try to submit this code. And our code runs pretty fast in terms of time and space complexity. Once again, the coding solution is available in our GitHub repository, and the link of the GitHub repository is in the description. So feel free to check it out from there. Thank you.